The original enterprise of sensation and perception research was really focused on psychophysics. So this lecture is going to talk a little bit about psychophysics and its cousin, signal detection. So originally, researchers were interested in absolute thresholds, or the smallest amount of stimulation that someone can detect. If you were a hearing researcher, you were studying the quietest sound you could hear. If you were a visual researcher, you were studying the faintest amount of light you could see. And if you were a taste researcher, you were studying the smallest amount of sugar you could taste in a solution, for example. So psychophysicists were trying to find these absolute thresholds. And one of the problems that emerged was that if they exist, there are some implications of that. And that means that if there is a threshold, then sensory stimulation or stimulus intensity, as it increases, you'll see no probability of detection. But then once we hit the threshold value, we'll go from no detection to absolute detection or 100% detection. And so the implications of absolute thresholds were that you would get a detection function that looked much like this. No, 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 I don't see it, I don't see it, I don't see it. Oh yes, I see it, I see it, I see it, I see it. But when we put these questions to the test, what we found was that the detection function was much smoother, and that is, as the stimulus intensity increased, people were like, well, maybe it's there, yeah, I think I see it, I think I see it, yep, it's there, it's there, it's there, yep. So this function called into question the existence of absolute thresholds, because if there were absolute thresholds, we would see a blue function, and what we actually saw in data was a red function. This led to the development of the theory of signal detection. And to set up the theory of signal detection, let's talk about uh, a test case, so to speak. And that is that imagine if you're asked to track enemy airplanes on a radar screen. This is a radar array, and there's a man sitting and looking for airplanes in his airspace, and periodically you have to report, you have to tell people, you have to tell somebody else what you've seen or not seen. So in reality, what they're asking is, are there any planes in your airspace? And if there is a plane in your airspace, and your answer is yes, there's an answer in your airspace, we call that a hit, and that is a correct response. Now, if in reality there's no plane in your airspace, and your answer is no, there's no plane in my airspace, that's a correct rejection. Now, there are other options, though, and that is if there's no plane in your airspace and you answer yes, that's what we call a false alarm, and that is a mistake. And if there's no plane, if there is a plane in your airspace and you say that there's no plane in your airspace, that's a miss, and those are wrong answers. Now, the detection of signals, the reason this has an implication for absolute thresholds is because certain features of experiments change, or certain features of this situation change what you see or what you detect. The likelihood or the probability that you will say something is there depends on features of the situation. So, for example, if you're in a time of peace, there's no war going on, enemy airplanes are unlikely to be in your airspace, and this changes what you see. This makes you less likely to see an airplane if there was one, and less likely to report that you saw one when no plane was there. In a sense, this says that you're less likely to have a correct rejection, but also less likely to have a false alarm. So what we see is that we see in peacetime, if there is a plane in your airspace, you have a small probability of saying there is one, but also a small probability that no plane is in your airplane. But if there is a plane in your airspace, often you will say, no, I don't see anything, because it's a time of peace, and there shouldn't be any enemy airplanes. Just as if there's no plane in your airspace, you might be likely to answer no. Now, in wartime, this situation might completely change, and that is that if there is a plane in your airspace, you're definitely going to see it, but you might even report that there's no plane in your airspace very, very intermittently. There's a very small probability that you will miss. Likewise, you probably will have an increase in false alarms. That means that there's no plane in your airspace and you say there is one. This is what we might call, crying wolf. But in a time of war, it might be important. So the detection of signals is dependent on the capacity of the sensory system, but it also depends on decision-making processes. And this is the essence of signal detection, is that absolute thresholds only take into account the first part of this. The second part is included because we know it impacts what we detect. So if you were in that radar array, you might say to yourself, should I sound the alarm? I thought I saw something, but I'm not really sure. Oh, what's the worst that can happen? We're in a time of peace after all. I'll just say that there was nothing there. Contrast that with, should I sound the alarm? I thought I saw it, but I'm not really sure. But we're at war, and if I don't say something, people might get killed. Okay, I'll sound the alarm. So in this case, you might have a miss. There was something there, but you say, there was nothing there. In this case, you would have, a hit. So our detection of signals changes with the situation and with circumstances, and that's the essence of signal detection theory, is that it doesn't rely on theories involving absolute thresholds, but it's probably the case that there is something like that. Signal detection theory, though, focuses on our concern on the detection of signals amongst background noise. This is sometimes referred to, as you may have heard of this, as the signal-noise ratio. Noise comes from multiple sources, internal and external, and it really can't be totally eliminated. It can't be totally eliminated because there are things like afterimages, and our perception does not mean that something was stimulated. For example, have you ever felt your cell phone vibrate in your pocket when it didn't? You're absolutely sure that it vibrated in your pocket, but it really didn't. This is a perceptual experience for which there was no stimulation. So this is background noise, and signal detection theory it is charged with analyzing detection of signals in this context of noise. It is ultimately a decision-making perceptual theory, but a very important one.